Good morning, my dear friends. I hope you all are doing great. So today we will be talking about the standard enthalpy of solution. So what is this standard enthalpy of solution? Let us understand. The enthalpy change when 1 mole of an ionic substance. So there is a change in enthalpy, my dear friends. So let's call it as delta H naught because it's a standard change in enthalpy. And we know that this is a standard change of enthalpy of a solution. So it's represented by SOL. You can also represent it as SOLN. Does not matter. So it is the standard change in enthalpy of a solution. And remember, this can be positive or it can be negative. Remember that particular point. It can be endo or it can be exo. So the enthalpy change of a solution can be endothermic or exothermic. We will understand it, don't worry. When 1 mole of an ionic substance, is dissolved in water to give a solution of infinite dilution. This is important here. So that means you are dissolving 1 mole of an ionic substance in water and you are making a solution of infinite dilution. Yes? So let us understand what is the meaning of that infinite dilution right out here. Okay? Have a look. Let us suppose I will take NaCl. This NaCl is with me an ionic compound. Okay? If I have a very less amount of water with me, then I can't call it as the infinite dilution. Yes? So I need to have here excess of water. So I need to have excess of water. That means I am dissolving an ionic compound, NaCl, 1 mole of NaCl in excess of water. Yes or no? Then what I am getting? I am getting Na plus and Cl minus. This aqueous represents that, the Na plus is present in water. And now Cl minus aqueous means it's present in water, my dear friends. So what is the important thing here? You are basically taking 1 mole of an ionic substance and we are dissolving it in water. How much of water? Excess of water, what we call it as infinite dilution, my dear friends. And when NaCl dissolves in water, it will break into Na plus and Cl minus. Now we have to understand that whether this process, that is a standard enthalpy of solution, is endothermic or exothermic. I told you that it can be endo or it can be exo. But if you look here, we are getting plus 4 kilojoules of energy right out here. Is it the energy released or energy absorbed? It is the energy absorbed. So it's an endothermic. So it's an endothermic process. So it means for the dissolution of NaCl in excess of water, we require 4 kilojoules of energy. So NaCl will consume 4 kilojoules of energy to dissolve in excess of water. And my dear friends, this is taken at constant temperature, means room temperature, 298. That is our, 25 degrees Celsius and 1 bar pressure. These are the standard conditions, my dear friends. Now what you have understood, my dear friends, the standard enthalpy of solution can be endothermic or exothermic. Yes, in this process we are dissolving the 1 mole of an ionic substance in excess of water. And once it dissolves in excess of water, it may release the energy or it may absorb the energy. Right now it is absorbing the energy. Let us take one more example here where it is releasing the energy. Take an example of NaOH, sodium hydroxide solid. This is also an ionic substance. Correct? Let us dissolve this thing also in excess of water. it will be your infinite dilution. Then what will happen, my dear friends? You will get here Na plus aqueous and OH minus aqueous. So NaOH has dissolved in water and has dissociated into Na plus and OH minus ion. In this process, if you see the delta H sol, that is solution, the standard enthalpy of solution is observed to be minus 41.6 kilojoules per mole. So my dear friends, this minus term will tell you that this is exothermic. So if when you dissolved NaCl in excess of water, energy was required. Yes? But when you dissolved NaOH in excess of water, the energy was released. Now you have finally understood that the enthalpy, the standard enthalpy of solution can be endothermic or it can be exothermic. When you dissolve NaCl in excess of water, it's endothermic. Energy is required for the dissolution. Yes, but if you look at this particular process, NaOH is dissolved in excess of water, the energy is released. Let us suppose if this process is carried out in one beaker, okay? So what happens if you touch the beaker here, in this case I am talking about. What happens? Lots of energy is released here. If you touch the beaker, it will be very hot. But when you just dissolve NaCl in water, okay? Energy is basically consumed. So if you touch the beaker in which this process is carried out, it won't be hot. It will be just cold only. Okay? The point is very simple, my dear friends. Very simple. That is, the standard enthalpy change of solution can be positive or negative. Now somebody will be still thinking of this infinite dilution. So let me tell you about this infinite dilution. Means excess of water. So it's related to the excess of water. Okay? So when it's related to the excess of water, if you add more water now to the solution, let us suppose if I add more water here, okay, the enthalpy change for the solution, okay, or enthalpy change for the solution will not take place, my dear friends. That means further change in enthalpy will not take place. Yes? So if the solution is already at infinite dilution, my dear friends, which means already excess of water is present. Okay? I will tell you here. Further addition of water will not change the value of delta H as well not. I will say that the solution is already at infinite dilution. Okay? Or it's infinitely diluted solution. That means excess of water is already present. Okay? So further addition of water will not change the value of delta H solution. My dear friends, how much is the delta H naught solution here? 4 kilojoules. If you add more water here, this value will not change, it will remain the same. If you add more water here, yes, this value will not change, it will remain the same because the solution is already at infinite dilution, my dear friends. So further addition of water will not change the enthalpy of the solution or standard enthalpy of a solution. So infinite dilution means excess of water. Okay? Further addition of water will not change the value of delta H of solution. Okay? Please remember this and make note of this. Dear friends, let us talk about the lattice enthalpy. It's of two types. Lattice enthalpy of dissociation and the lattice enthalpy of formation. Okay? So let us understand what is this lattice enthalpy, the standard lattice enthalpy of dissociation and the lattice enthalpy of formation. In case of dissociation of 1 mole of ionic crystal. Here we are breaking 1 mole of ionic crystal into its constituent gaseous ions. Okay? We can also mention here into constituent gaseous ions. So here you are breaking 1 mole of ionic crystal into constituent gaseous ions. And here formation of 1 mole of ionic crystal from constituent gaseous ions. So my dear friends, if you look at the first one, it is dissociation. So dissociation reactions or process are always endothermic, and this is formation, so it will be exothermic. So here the delta H value, delta H naught value will be here positive, endothermic, and in this case delta H naught value will be negative, that is exothermic. So now my dear friends, in case of dissociation, you are breaking 1 mole of ionic crystal into constituent gaseous ions. And in case of lattice enthalpy of formation, you are forming, it's a formation of 1 mole of ionic crystal from constituent gaseous ions. Here is the formation and here is the dissociation. And during dissociation process, energy is required. So it's endothermic, and the formation process is exothermic, my dear friends. So let us come to the first point here. Let me take on the first point. What is that? Lattice enthalpy for dissociation. So the amount of energy required to dissociate 1 mole of an ionic crystal, which I have already mentioned here, dissociation of 1 mole of ionic crystal into constituent gaseous ions. So same, into its constituent gaseous ions at constant temperature and 1 bar pressure, my dear friends. Let us talk about now NaCl. Okay, if we heat NaCl, but heat must be supplied at constant temperature. Yes, so if you heat the NaCl, which is solid, and this NaCl can be called as ionic compound, or it can call it as ionic crystal. And how many moles you have? You have 1 mole. 1 mole of NaCl, that ionic crystal. You are heating it up. It will break into Na plus and Cl minus. But here Na plus is gaseous and Cl minus is also gaseous. And we call them as constituent gaseous ions. So you are breaking 1 mole of NaCl into constituent gaseous ions. And this is what we call as lattice enthalpy of dissociation. Now let us see that how much of energy is required for breaking 1 mole of NaCl crystal. You require this much of energy, 788 kilojoules per mole. This much of energy is required. So we need 788 kilojoules of energy to break 1 mole of ionic crystal of NaCl into Na plus gaseous ion and Cl minus gaseous ion. So this is all about the lattice enthalpy of dissociation, my dear friends. Now, look here. If we talk about now lattice enthalpy of formation, I told you in previous concepts that the dissociation, if it is a forward reaction, then the formation will be the backward. So dissociation and formation of NaCl, okay, are exactly opposite of each other or reverse of each other. That means if the dissociation value is 788 kilojoules, this much of energy is required to break 1 mole of NaCl, then how much of energy will be released during the formation of 1 mole of NaCl? That will be minus 788 kilojoules, my dear friends. So here, look here, my dear friends. If I write down the definition of this, it will be the amount of energy released when 1 mole of ionic crystal is formed from its constituent gaseous ions. That means the reverse of this. So let's take the reverse of this, my dear friends. Na plus gaseous plus Cl minus gaseous. Yes. So what will happen? I will get NaCl solid. So I am taking the reverse of this, my dear friends. Na plus gaseous plus Cl minus gaseous. They will react and will give me 1 mole of NaCl. So I am getting 1 mole of NaCl. So it is the lattice enthalpy of formation. And during this process, delta H lattice, and this is for the formation. So obviously, here the dissociation is requiring 788 kilojoules of energy. Then the formation will also release the same amount of energy will be released. So it will be minus 788 kilojoules per mole. Now I hope you have understood the things. The lattice enthalpy of dissociation is the reverse of lattice enthalpy of formation. Which means what? That if the lattice enthalpy of dissociation value for NaCl is 788 kilojoules, then the lattice enthalpy of formation for NaCl will be reverse of that. That is minus 788 kilojoules, my dear friends. So this was all about the lattice enthalpy. Means lattice enthalpy of dissociation, lattice enthalpy of, come on, formation, or we can say association. Please remember this concept and make note of this. Dear friends, let's talk about now standard hydration enthalpy. Okay, what is the meaning of term hydration? We will understand here. Hydration. Hydration basically means addition of water. Addition of water. Correct? And there is one more term, solvation also. Solvation means addition of a solvent. Of a solvent. You know that our water is nothing but it's a solvent only. Water is a solvent. So that's why I wrote the term hydration or solvation. But remember, solvent is not always water. You can change the solvent. Yes? In place of water, if you use benzene. Yes? So that is also a solvent. Nitric acid is also a solvent. Ether is also a solvent. But we are talking about here water. And water is also a solvent. So what is the standard hydration enthalpy? The enthalpy change when 1 mole of gaseous ions undergo hydration, means when you are adding water to the 1 mole of gaseous ions. That is called as hydration enthalpy. Because during the addition of water, when you add water to the gaseous ions, what will happen? The energy will be released. That means it's an exothermic process. So remember, standard hydration enthalpy is always exothermic. So I will write down always exothermic. That means energy will be released. Now I took 1 mole of sodium ions, or you can take 1 mole of Cl minus ions. In which state? Gaseous state. So you are taking gaseous ions, 1 mole of Na plus, or you can take 1 mole of Cl minus. You can calculate its hydration enthalpy separately for this mole. And you can also calculate the hydration enthalpy of this mole separately. But I am taking their hydration enthalpy together. That means I have already calculated for Na plus and already calculated for Cl minus. So 1 mole of gaseous ion, that is 1 mole of gaseous sodium ion, and 1 mole of gaseous chlorine ion. Now you will be thinking that where from you got those gaseous ions, my dear friends? Just recently I told you about lattice enthalpy of dissociation. I told you about lattice enthalpy of dissociation. In this lattice enthalpy of dissociation, I took, my dear friends, NaCl crystal and I applied heat to this and I got Na plus gaseous plus Cl minus gaseous ions. And during this process, the value of this was coming out to be 788 kilojoules per mole. That's an endothermic. This is an endothermic process. I have broken 1 mole of NaCl solid and converted that into sodium gaseous and chlorine gaseous ion. Now very simple thing. Now these ions you can take here. I am taking them here, my dear friends. So first of all, I have broken NaCl crystal into gaseous ions. Now for these gaseous ions, I am adding water. So I am doing the hydration now, my dear friends. Once again, I took ionic crystal solid. I applied heat I have broken it into the gaseous ions. Yes? And this much of energy was required. That means endothermic. Because you are breaking NaCl into gaseous ions. Now I am taking these gaseous ions here and I am adding water. To this 1 mole I can add water separately and I can add water separately to this mole also. It's your choice. So I am adding water to them. Addition of water to the ions will give me this is hydration process. And in this hydration process now, Na plus gaseous will become Na plus aqueous, means with water. Cl minus gaseous will become Cl minus aqueous, means with water. So water has been added, and this addition of water is hydration, my dear friends. And during this hydration process, we know that it's an exothermic reaction or exothermic process. In this exothermic process, what happens? Energy is released. So how much of energy is released during the hydration of Na plus gaseous ions and Cl minus gaseous ions, my dear friends? Minus 784 kilojoules per mole. This much of energy is released. And hydration is exothermic, but the lattice enthalpy of dissociation is endothermic. Remember, I am writing here dissociation. If you talk of formation, then that is exothermic. But remember, we are talking about dissociation here. So lattice enthalpy of dissociation is endothermic, but the standard enthalpy of hydration is always exothermic, my dear friends. So when you know these things, let me make you understand it by just a little bit explanation here. What happens actually in the hydration process? Have a look. Let us suppose we have sodium gaseous ion. Okay? And it is dissolved in water. I am putting it in water. So water will be added to this. Okay? Have a look. You know the water molecule, my dear friend. This is our water molecule. And you have also read, yes, in chemical bonding chapter you have read the dipole. This is plus and this is minus. You can also call it as, we know the charges. Charges of hydrogen basically is slight positive and here is a slight negative charge. This is a dipole. Because there is a little difference in the, electronegativities. So electron will shift. This sigma electron will shift towards the more electronegative element. You have read already in chemical bonding. So this is our dipole. Now this dipole will interact with the ion. And we call it as ion-dipole interaction. Ion-dipole interaction. And this ion-dipole interaction will be nothing but it will be your hydration, my dear friends. Why? Because you are adding water. Water will be added to this particular cation, which is sodium ion. So when you add water to this, it has a charge. So positive charge will attract the negative charge and hydration will happen. So the representation will be like this, my dear friends. If you have a sodium gaseous ion, my dear friends, okay, in order to change it into aqueous, what we do? We will bring the water molecule. We know that oxygen of the water molecule, remember, oxygen of the water molecule is negative. So this negative will attract this positive. So bring one more water molecule here. Oxygen is negative, it will attract this positive charge. Bring one more water molecule here. And it will attract this positive charge. Bring one more water molecule. It will attract this positive charge. And this is the hydration, my dear friends. This is how the hydration of Na plus will happen. And remember, this is not one Na plus. Understand that we are talking in terms of moles. This is 1 mole of Na plus. And you are doing its hydration. And during this process, energy will be released. So here delta H hydration will be minus. Energy will be released when you are adding water to the ion. In the same way, on the other hand, we will have a chlorine ion with us. Let's have a look. Cl minus we can have. And you know that water is a dipole. This is a dipole. And you know the charge here, slight positive and slight negative. So this is the direction, plus to minus. Now water has to come like this. Because you know that hydrogen has a positive charge. It will attract the negative charge of chlorine. So now this has a positive charge, it will attract the negative charge of chlorine. And now if you look here, let's suppose we'll take it like this. We know that hydrogen has a positive charge, so there is attraction. So my dear friends, now in this process also, energy will be released. So whether you are hydrating a sodium ion, cation, or whether you are hydrating an anion, in both the processes energy will be released. So I am showing in this process all together. I am hydrating Na plus and hydrating Cl minus. Yes or no? And somebody may be thinking that you have only one water molecule. Don't think you have one water molecule here. You have basically water in terms of moles. And if you have a 1 mole of a water, that's equal to 6.022 into 10 raised to 23 water molecules you have. And even if you want, you can write down n times also, does not matter. Okay? So what is important here? When you are hydrating Na plus or Cl minus ion, we call it as ion-dipole interaction. This is ion and this is the dipole. And here also we have ion and this is dipole. So this is also ion-dipole interaction. Through ion-dipole interaction, what happens? Energy is released. So these are both exothermic, my dear friends. So the standard, total standard enthalpy of hydration for NaCl, like Na plus and Cl minus gaseous ions, is minus 784 kilojoules per mole, and this is exothermic, my dear friends. I hope everybody has understood among you. Please make note of this. Dear friends, you have understood standard enthalpy of solution, lattice enthalpy, that is lattice enthalpy of dissociation and lattice enthalpy of formation, both. And you have also understood the hydration enthalpy, the standard hydration enthalpy. Let us try to find out the relationship between them with respect to our NaCl, which is an ionic crystal, ionic substance. So let us understand, my dear friends. Previous time I have told you about Hess's law. Yes? So here we will apply the Hess's law and find out the relationship. Okay? So my dear friends, what is the relationship? Have a look. Delta H, okay, solution is equal to delta H lattice. And remember, my dear friends, this is very much important. In your books, they are not mentioning this particular point. You should mention it's a lattice enthalpy of dissociation. Yes, plus delta H naught hydration. So my dear friends, if you remember the Hess's law, I told you the standard enthalpy change for the formation of compound A in one step is equal to the sum of the standard enthalpy change for the formation of same compound A in multiple steps. Same is the case here. Have a look. Let's understand this relationship. We are taking one compound NaCl. Okay, that is solid. Then what happens here, my dear friends? We are introducing the concept of standard enthalpy of solution concept. That means we are breaking this NaCl into Na plus aqueous and Cl minus aqueous. So this is just in one step we are basically dissolving NaCl in water and I am getting Na plus aqueous and Cl minus aqueous. So this is a one-step process of conversion of NaCl solid into Na plus aqueous and Cl minus aqueous. So the value of the energy is this much here. So how much of energy is required? It's an endothermic process. 4 kilojoules per mole. 4 kilojoules per mole energy is required to convert 1 mole of NaCl solid into Na plus aqueous and Cl minus aqueous. So it's a one-step process, my dear friends. So I will call it as one-step process. One-step process. Now look at here, my dear friends. I will do the same thing, but in multiple steps now. I am doing the same thing in multiple steps. Have a look. First of all, I am taking NaCl solid. Then I am giving energy, that is basically called as standard lattice enthalpy or lattice enthalpy of dissociation. I am breaking NaCl first into Na plus gaseous and Cl minus gaseous. Yes or no, my dear friends? That means I should reach here. But in one step, I am applying the lattice enthalpy of dissociation and I am getting gaseous Na plus and Cl minus. Then after that, I am doing the hydration. I will add water to these gaseous ions. After adding water to these gaseous ions, my dear friends, I will reach here. That is, I will get Na plus aqueous and Cl minus aqueous. That means I am doing the same process. Same process means I am getting Na plus aqueous and Cl minus aqueous. But here, two steps are involved in this process. Yes? So NaCl is directly converted into Na plus aqueous and Cl minus aqueous in one step. But here, have a look, my dear friends. We are again doing the conversion of NaCl solid into Na plus aqueous and Cl minus aqueous. But here we require two steps, step number 1 and step number 2. So two steps are required here. That's why I told you this is a one-step process and this is a two-step process. The end result is same. What is the end product here? Na plus aqueous and Cl minus aqueous. But what is the end product here? Same, Na plus and Cl minus aqueous. Look here, in this process what I am doing, I am converting Na plus solid directly into Na plus aqueous plus Cl minus aqueous. But here, if you look at them, in first step what I am doing, I am taking NaCl solid, I am converting it into Na plus gaseous and Cl minus gaseous. Then in second step I am taking Na plus gaseous, okay, and Cl minus gaseous. I am adding water. By the addition of water, what I am getting? I am getting Na plus aqueous and Cl minus aqueous. This is our, here we require the lattice enthalpy of dissociation and here we require the lattice enthalpy of hydration. That's delta H hydration and that is delta H lattice. So final result is Na plus Cl minus aqueous and final result is Na plus and Cl minus aqueous. Here I am getting the Na plus and Cl minus in one step and here I am getting the Na plus and Cl minus in two steps. First of all, I am converting NaCl into gaseous ions. Gaseous ions I am doing hydration, means addition of water, and final result is the same. Whatever I am doing in one step, the same thing I am doing in multiple steps. So enthalpy change, the sum of the enthalpy change here will be equal to the enthalpy change here in one step. Or we can say that the standard enthalpy of what? Solution will be equal to the sum of the standard enthalpies of what? Lattice and hydration, my dear friends. So let's apply that values now here. So you are doing actually the Hess's law you are applying basically here. So let us talk about now how much is the value of this. This is 4 kilojoules per mole. How much is the value of lattice? You can find out the lattice value of dissociation is 788. So this guy is 788. Then plus how much is the hydration value? Minus 784. That is minus 784. Now my dear friends, you can tell me how much is the difference here? 4 and how much is here? 4. So finally I can write down here at the end. Let me remove this thing now. 4 kilojoules per mole is the value here in one step. And sum of these enthalpies will also give me 4 kilojoules per mole. That means LHS is equal to RHS. And that's all about our Hess's law. Hess's law states that the enthalpy change or standard enthalpy change for the formation of compound A in one step will be equal to the sum of the enthalpy change or standard enthalpy change for the formation of same compound in multiple steps. So their sum of these two steps is equal to this one. Hence proved. So obviously Hess's law we have applied here, my dear friends. And I hope you have found the relationship between, the standard enthalpy of solution and hydration enthalpy and lattice enthalpy. Please remember this particular thing. Make note of this. Dear friends, let us talk about now enthalpy of dilution, my dear friends. Dilution means actually addition of water. Yes? But you will find out in this particular process we are adding the solute, not the solvent. Because I will tell you the reason why we are adding something. Okay? Have a look. Enthalpy of dilution here, I have not taken it in under standard conditions, my dear friends. You can take it under standard conditions also, it's your choice. Now let us see the definition. The change in enthalpy associated with, the meaning is change in enthalpy, that is our delta H, okay, associated with the addition of a specified amount of solute. Yes? Usually in dilution, remember, in dilution you are adding water, but here I am adding the solute, not water. Yes or no? To the specified amount of solvent. That means you have a specified amount of solvent, yes, is known as enthalpy of dilution. So let us understand this particular process. Have a look here. If you have HCl here with you, my dear friends, that is gaseous, okay, and you have water, that is liquid. In place of water you can use term AQ, aqueous. So water can be replaced by AQ. In these process you will find out 10 AQ. 10 AQ basically here means 10 times H2O, that is aqueous only. This is 25 times water, 40 times water, and this is infinite, okay. Now look here, this is your solute, okay. You will add this 1 mole of solute you are adding to this water. Let us suppose this is 1 mole of water. You are adding 1 mole of HCl gaseous and you are dissolving it into 1 mole of water, my dear friends. Remember always, acid should be added to the water and water should not be added to the acid. Because if you add water to an acid, what will happen? It's highly exothermic process. Lots of energy will be released at the same time. And the beaker in which you are carrying out the process will also explode. So remember, you have to add acid to the water. Remember, I am adding acid to the water. And don't add water to the acid. And when you are adding acid to the water, you have to do it very slowly. Yes or no? So now, my dear friends, look at this process. I added 1 mole of HCl, I am adding to 10 moles of water here. And then I am adding same 1 mole of acid to 25 moles of water. Then I am adding 1 mole of HCl to 40 moles of water. Then I am adding 1 mole of HCl to infinite number of moles. This infinite actually basically here means excess of water. Don't think that here infinite means that you will take the water of the whole, world. No. It is just the excess of water. Yes. Now what is my point? You are adding HCl to the water, HCl to the water, HCl to the water, HCl to the water. What is changing here? The number of moles of water are changing. 10 moles, 25 moles, 40 moles and infinite means excess of water. That means when the water is changing, in these process you have found that the water, the term for water we are using aqueous. Yes. So this is basically increasing 10, 25, 40 and infinite. That means water is increasing. When water increases, what happens? Remember, dilution also increases. That means you are doing the dilution. Now look here, my dear friends. When HCl is added to the water, you will get a solution of HCl. This is HCl 1 mole and 10 moles of water. So it's a solution. So you got a solution here. Correct? Then 1 mole of HCl is dissolved in 25 moles of water. And you got a solution here. So obviously, everywhere you are getting a solution, you will get here a solution of HCl in water. Because you know that this water is nothing but it's a solvent. Now you find out the dilution is happening. Water is increasing. 10 moles, 25 moles, 40 moles and infinite. That means water is increasing. And when water increases, dilution process is also increasing. Now look here, my dear friends. When you are adding 1 mole of HCl to 10 moles of water, how much of energy is released? 69.01 kilojoules. And when you are adding the same 1 mole of HCl into 25 moles of water, how much energy is released? 72.03. Then you can calculate the difference in the energies here. That is 72.03 minus what? 69.01. So calculate this difference. That how much is the difference in energy when 1 mole of HCl is dissolved in 10 moles of water and 1 mole, the same 1 mole of HCl is dissolved in 25 moles of water. There is a difference in energy. Look further. The same 1 mole of HCl is dissolved in 40 moles of water. Look at the energy. Energy has further increased. So when you keep on increasing the amount of water, the number of moles of HCl are constant. So here, moles of HCl are constant. And how much is that? 1 mole only. We have only 1 mole of HCl in every case. But only water is variable, it's changing. So dilution is also increasing here. So look at these all process. You will see that more and more energy is released when we increase the amount of water. This guy is constant. Finally, we are reaching to the infinite dilution, where there is an excess of water is present. And how much of energy is released? Minus 74.05 kilojoules, my dear friends. This much of energy is released. Yes? When you dissolve 1 mole of HCl in excess of water, this much of energy is released. Then remember one point. If you add further water after infinite dilution, yes, delta H value will not change. Remember that much. If further water is added to after infinite dilution, the delta H value will not change. Delta H value is changing and changing. Now you have reached to the infinite dilution, my dear friends. And this is infinite dilution. Infinite dilution means excess of water is already there. Large amount of water is already there. If you add more water now, yes, what will happen? Do you think this delta H value will change? No, it will remain the same. If you add 1 more bucket of water also here after this, the value will remain the same. Value will not further change. That means the enthalpy of enthalpy of dilution value does not change. Yes, after infinite dilution. Till infinite dilution, this value was changing. But after this, now this value will be constant. If you add more water now, after infinite dilution, if you add more water, the delta H value will not change. The delta H value will remain constant. Yes? So I hope everybody has understood my point. Take care of yourself. Have a great time. Yo-yo.